A hydraulic cylinder converts the energy of a liquid flow into linear motion, and to move the arrows of excavators, lifting machines, move tools, carry out technological operations. In this video, we'll try to figure out how a hydraulic cylinder works, what elements it consists of. Let's look at several typical designs of hydraulic cylinders. Understanding how a hydraulic cylinder works is simplified by a basic example. Let's take a syringe. Let's fill it with water and press the rod connected to the piston. Water will flow out of the syringe, meaning it allows pumping water, meaning it acts as a pump. Let's connect a water-filled syringe to an empty syringe with a tube. Press the rod of the pump syringe. The liquid will enter another syringe, causing its rod to extend. This syringe acts as a hydraulic cylinder. This principle also underpins the operation of a hydraulic drive. Fluid under pressure enters the cylinder chamber and displaces the piston to which the rod is attached. A syringe and fluid can only act on the piston from the piston side. In single-acting hydraulic cylinders, the fluid can also act on the piston from one side only. The reverse retracting motion of the rod can be performed under the action of external forces. For instance, the weight of the load or the force of the spring. An example of a single-acting hydraulic cylinder is the cylinder of a jack. To extend the rod of this cylinder, fluid needs to be supplied from the pump plunger. To retract the rod, just need to allow the liquid to flow out of the cavity. The rest of the work will be done by the mass of the lifted load. But what to do if the hydraulic cylinder needs to overcome forces both during the forward and reverse movements? The design needs a bit of tweaking. Add a hermetic rod chamber through which fluid can also act on the piston. When fluid is supplied to the piston chamber, the rod will extend. During this, it's necessary to allow the fluid to drain from the rod cavity. To retract the rod, fluid must be supplied to the rod cavity, and for the fluid from the piston cavity, a path to the drain tank must be opened. It turns out that to move the rod of the hydraulic cylinder, it's necessary to control the fluid flows. For these purposes, there are special devices, hydraulic distributor. Recently, a new video about this device appeared on our channel. We recommend watching it. We've already used two terms common in describing the components of a hydraulic cylinder's construction. Let's define the rest. The cylinder body is formed by sleeves and covers, which have channels for the inflow or outflow of fluid. The front cover has a hole through which the rod moves. The covers are placed, a gasket to prevent fluid leakage from the cylinder along the rod, and a dirt scraper that removes dust and dirt from the rod, preventing contaminating particles from entering the cylinder body. At the junctions of the sleeves and covers, there must be seals. Otherwise, fluid will leak from the hydraulic cylinder. The sleeve houses the piston. It is fitted with seals that ensure airtightness, ensure that the piston and rod move with little friction. The rod is attached to the piston, secured by a nut. A rubber ring is installed at the piston and rod connection to prevent fluid leakage. The space formed by the surfaces of the piston liner and back cover is called the piston cavity. The opposite cavity, formed by the surfaces of the piston rod liner and front cover, is called the rod cavity. When fluid enters the piston cavity, the rod will extend and fluid will be forced out of the rod cavity. At this point, it is connected to the drain. When fluid enters the piston rod cavity of the cylinder, the piston will retract. The fluid from the piston cavity will be displaced. The area of the piston that can be pressurized by the fluid is called the effective area. The fluid pressure is referred to as the effective area. Let's look at several typical hydraulic cylinder designs. Round hydraulic cylinder. The piston is mounted on the rod and secured with a nut. The piston is fitted with two collars to ensure hermetic separation of the piston and rod cavities and a guide ring. The piston is placed in the sleeve, in which the back cover is pre-welded. The front cover is fastened to the sleeve by means of a threaded connection and secured with a lock nut. The front cover contains a collar to ensure tightness of the rod cavity, and a dirt collector to remove contaminants from the cylinder rod. The tightness of the connection between the cap and the sleeve is provided by a rubber ring. There are special channels in the caps for liquid supply. The inner surface of the sleeve and the outer surface of the rod are polished to ensure that the collars are not damaged and provide a tight seal. Air-anchored hydraulic cylinder design. In this design, the caps are attached to the liner by means of studs. The tightness of the connections between the caps and the sleeve is provided by rubber rings. In the front cover, there is a collar for sealing the rod. The piston has seals to separate the piston and rod cavities. As an example, this cylinder utilizes a reduced friction seal. To prevent fluid from flowing between the rod and piston, a groove is provided on the rod where a rubber ring is installed. As it is known, the force developed by a hydraulic cylinder is defined as the product of pressure and effective area. On the side of the piston cavity, the effective area is the entire area of the piston. And on the side of the rod cavity, the effective area is the area of the ring formed by the outer diameters of the piston and rod. It turns out that, all other things being equal, a hydraulic cylinder can develop more force when
extending than when retracting. For this reason, the actuator is designed so that the operating stroke occurs during the extension stage of the rod. The speed at which the rod extends will be determined by the fluid flow rate to the hydraulic cylinder and the volume of the cavity. The volume of the rod cavity will be smaller than the piston cavity because part of the space in
This means that the rod will retract faster than it will extend. This means that the performance of the hydraulic cylinder in forward and reverse stroke will not be the same. What should we do if we want the same performance in both directions of travel? Use a hydraulic cylinder with a double-sided rod. Let's install 2 front caps in the cylinder and attach 2 rods to the piston. Now the volume and effective areas of both cavities will be the same, and we will get the same forces and velocities regardless of the direction of rod movement. Hydraulic cylinders with a double-sided rod are most often used in steering mechanisms. They are used in the power steering system of a car, in the steering drives of airplanes. Fluid in the cavity of the hydraulic cylinder can be supplied not only through the caps, but also through the rod. Let's fix the rod and supply the fluid. The body of the hydraulic cylinder will move. The stroke of the hydraulic cylinder is determined by the distance from the cover to the piston. If a larger stroke is required, the hydraulic cylinder itself will have to be made long. But what to do if the dimensions are limited? It is necessary to use a telescopic hydraulic cylinder. This type of hydraulic cylinder is built on the principle of a telescope. The hydraulic cylinder rod consists of sections inserted one into another. Consider the operation of a telescopic cylinder of single acting. When the fluid is supplied, the largest diameter section will be the first to extend, as its effective area is larger than the others. When the first section reaches the end position, the second section will start to extend and so on. The telescopic hydraulic cylinder is moved by an external load. The hydraulic cylinder under the action of an external load. It is only necessary to connect the internal cylinder cavity to the drain line. To ensure smooth lowering, the fluid can be drained through the throttle. Hydraulic resistance. In a double-acting telescopic hydraulic cylinder, provision must be made to supply fluid to the opposite cavity. When fluid is supplied to the inside cavity of the cylinder, the rod will extend. In order to retract the telescopic rod, fluid must be supplied to the opposite cavities. In the following videos on our channel, we will consider the operation of various hydraulic actuators, steering, lifting, technological, and none of them can do without a hydraulic cylinder. And none of them can do without a hydraulic cylinder. Write in the comments the work of what device you would like to see, and we will certainly take your wishes into account when creating new videos. Igor Negoda was with you.